Did you know that the moon is not as calm and still as it appears to be? Hidden beneath its surface is a world of activity most of us are unaware of. In fact, the moon is an active and vibrating body, and we've caused some of these vibrations ourselves. The Apollo missions left behind technology that still causes tremors on the moon to this day. In this episode, we'll take a closer look at this fascinating phenomenon of moonquakes and explore some of the most intriguing theories surrounding these strange vibrations. So buckle up and let's dive into the mysteries of our celestial neighbor. The abandoned Apollo 17 lunar lander module is causing tremors on the moon. You won't believe what's been happening on the moon. Every single morning and afternoon, the lunar surface shakes and quivers with small tremors, almost like clockwork. But here's the kicker. A new analysis of the moon's seismic activity has revealed that not all of these quakes are what they appear to be. The moon's lack of atmosphere leaves it vulnerable to dramatic temperature fluctuations, ranging from a searing 250 degrees Fahrenheit during the hottest part of the day to a bone-chilling minus 208 degrees Fahrenheit at night. These extreme temperature swings cause the moon's surface to expand and contract, resulting in small tremors and fractures near the surface, known as thermal moonquakes. The movement caused by these moonquakes, while not visible to the naked eye, is nevertheless significant, and it serves as a reminder of the moon's constantly shifting and evolving nature. During the 1970s, the Apollo 17 mission experimented on the moon by placing 3 seismometers specifically designed to measure thermal moonquakes. These seismometers collected data from October 1976 to May 1977 for 8 months. The data remained largely unexplored for many years until a new study emerged. In this study, the lunar seismic data has been reanalyzed with modern techniques such as machine learning, enabling scientists to better understand the moon's internal structure and composition. The reanalysis has revealed fascinating insights into the moon's geology, including previously unknown seismic events during the mission, shedding light on the moon's history and evolution. Francesco Civillini, a brilliant Caltech postdoc, has led a groundbreaking study that has revealed some fascinating facts about the moon. Did you know that thermal moonquakes happen like clockwork every afternoon when the sun begins to set and the lunar surface cools off? But that's not all. The research team's machine learning model also picked up weird morning seismic signals that differed from the predictable evening earthquakes. After some intense investigation, the team made an unexpected discovery. Those morning tremors were actually originating from the Apollo 17 lunar lander base just a few hundred meters away. As the structure warmed up and expanded, it produced shuddering vibrations picked up by the seismic array. Amazing, right? Why is understanding lunar activity so crucial? The understanding of lunar activity is of utmost importance as NASA plans to embark on the Artemis mission to return astronauts to the moon within the next few years and eventually establish a permanent lunar base. The recent discovery of thermal moonquakes gives researchers essential insights into the thermal contraction and expansion that future lunar landers and equipment should be designed to withstand. Even though thermal moonquakes are too small to be felt by humans standing on the moon's surface, they can cause significant damage to sensitive equipment. According to Husker, who conducted the study, it is highly probable that landers from previous Apollo missions also experienced these creaking vibrations and expansion phenomena. Still, the seismometers used during those missions were designed to measure different frequencies than thermal moonquakes. As a result, this new knowledge is critical for the successful planning and execution of future lunar missions and for establishing a permanent human presence on the moon. Studying seismic activity on both the Earth and the moon is crucial to gaining insight into what lies beneath the surface. By analyzing the seismic waves and signatures generated by earthquakes, scientists can determine the composition of materials that are present underground. This information benefits researchers looking to study the moon, as it can help them map out the subsurface cratering and locate potential deposits. One area of interest for researchers is the permanently shadowed regions found in the moon's South Pole craters. These regions never receive sunlight, so that temperatures can drop to as low as minus 240 degrees Celsius. By placing a few seismometers in these regions, scientists hope to detect the presence of water ice that may be trapped beneath the surface. This is because seismic waves travel slower through water than other materials, which means that any changes in the speed of seismic activity could indicate the presence of water ice. Overall, studying seismic activity is an incredibly valuable tool for scientists exploring the Moon and gaining a deeper understanding of what lies beneath its surface. Despite the absence of plate tectonics or volcanic activity, the Moon's internal structure remains a topic of great interest and exploration among researchers. Husker, an expert in the field, emphasizes the significance of leveraging existing data to formulate hypotheses that can guide future experiments and missions. The Moon is the only celestial body besides Earth that has had more than one seismometer deployed on its surface at a given time. This provides an unparalleled opportunity to conduct an in-depth study of another planetary body and gain invaluable insights into the mysteries of the universe. Other seismic activity. Did you know the Moon experiences more than just the occasional thermal quake? In fact, it's been known to have deep and shallow tremors caused by meteorite strikes. And while the lack of shifting tectonic plates on the lunar surface may seem reasonable, it's important to note that the Moon has an active interior life much like Earth. This means certain seismic events can occur on the lunar surface at any time or location. But don't worry, the researchers are optimistic that future lunar missions will uncover more about these fascinating phenomena. Dr. Angela Maruziak, an assistant research professor at the Lunar and Planetary Laboratory of the University of Arizona, expressed great interest in Chandrayaan-3, India's lunar lander mission equipped with a seismometer. The Indian Space Research Organization, or ISRO, has confirmed that the instrument successfully detected a moonquake. However, ISRO researchers still need to disclose detailed data regarding the recording or suggest a possible cause for the event. Regarding the Artemis program, Maruziak hopes that seismometers will continue to be included, as they are crucial for understanding the surface and the deeper layers of the regolith or soil. This will provide valuable insight into the lunar geological processes and help facilitate future exploration. Although the Apollo-era data has existed for several decades, scientists believe modern technology can reveal new and exciting information. With advanced analytical tools and techniques, researchers are optimistic about the potential discoveries that can be made by exploring this data. Combining old and new technology can provide deeper insights into the mysteries of the cosmos and help us better understand our place in the universe. Is there any device or algorithms to predict moonquakes? As part of their study, researchers worked on developing algorithms that could accurately determine the arrival timing of seismic waves, measuring their strength, and identify the direction of the source. The researchers identified two primary sources of shaking on the Moon through their efforts. Firstly, they identified the vibrations caused by the lunar module left on the Moon's surface by the Apollo 17 astronauts during the seismic recordings. Secondly, the researchers found that thermal moonquakes were also causing shaking on the Moon. In addition to these findings, the researchers noted that the temperature on the Moon's surface appeared to affect the duration of the shakes recorded during moonquakes significantly. Specifically, warmer temperatures were associated with more extended readings on the seismogram records, indicating longer shakes during the duration of the moonquakes. The researchers hypothesized that these temperature changes may affect the properties of the rocks and materials on the Moon's surface, resulting in more prolonged and vigorous shaking during moonquakes. In conclusion, the discovery that the abandoned Apollo 17 lunar lander module is causing tremors on the Moon is a fascinating revelation that sheds new light on our understanding of the Moon's internal structure and composition. Researchers have unlocked a wealth of previously unexplored information, which will be invaluable as NASA plans to return astronauts to the Moon and establish a permanent lunar base. By studying the seismic activity on the Moon, we can gain a better understanding of what lies beneath the surface and locate potential resources that can be utilized for future space exploration. It's an exciting time for space exploration, and with each discovery, we are one step closer to unlocking the mysteries of our celestial neighbor. We hope you've enjoyed this video. Please be sure to share your thoughts down below, and don't forget to subscribe to our channel for weekly space updates. See you next time.